So I think let's get started. We have plenty to talk about. So can everybody hear me okay? That's great, thank you. If I stand in the wrong spot, I get feedback. Maybe I should stand over here. Okay, that's better. Thank you everyone for coming. I hope you're enjoying the conference. I'm here to talk about what's new in Azure networking. My name is Jonathan Tuliani. I'm a program manager in the Azure networking team. And I'm here with my colleague Ganesh. He's going to share this talk with me to introduce some of the exciting things that we've been working on that are now lighting up in the Azure networking space. So thank you all for coming. And we'll be taking questions at the end as well. So if there's anything that you want to find out more about, then please feel free to ask. So there's three main sections to the talk today. We're going to talk about highly available services and the things you can do within the data center and across data centers to achieve that. We'll talk a little bit about how you manage IP addresses and ACLs and virtual network IP addresses. Some changes we've made there, some new features that we'll talk about there that address some key scenarios and make certain things much simpler to do. And we'll also talk about what we call cloud connectivity. We recognize that very often you'll want to connect your cloud services to things that are running on your local premises in various different ways, whether it's a line of business application or simply a back-end database or for whatever reason. And there's various options for how to achieve that in Windows Azure, and we'll talk about those as well. So I mean a brief summary here of what we'll be talking about. We'll talk about Traffic Manager. This is generally available since November, that was. And we'll talk about, as mentioned in the keynote this morning, the Traffic Manager support for Azure websites. We'll talk about IP addresses, how to set up static IP addresses for machines within a virtual network, which addresses some key scenarios for how you set up virtual networks. And we'll talk about how you can move machines within a virtual network much more easily than previously. We'll then talk about connectivity, point to site, which is a new kind of connectivity that we will have in Windows Azure. And we'll talk about other ways of routing, more VPN devices that we're supporting, and most interesting of all, the ability to set up private dedicated connections into Windows Azure, which we call Express Route. For the Americans, Express Route. I'm based in Dublin in Ireland. You can probably hear the accent. I'm based in Dublin in Ireland. I'm English, so there's a few pronunciation differences we have. Express Route for the Europeans in the room. Okay, so let's go into the first of these sections. The next couple of slides are really an overview of some of the existing features that have been in Azure for a little while, and it's to give you context on some of the stuff that will immediately follow. So let's talk about some of the existing connectivity options in Azure. Firstly, there's this idea of an input endpoint. So this is a VIP. It's it's an IP address where you can receive connections from outside of Azure coming into your service, and these come through a load balancer. And then you can have multiple instances, running behind that load balancer. And that could be for a PaaS application or a IaaS application. I'll talk more about IaaS in a minute. And you can set up multiple ports. Each endpoint has a particular port. And you can, of course, use HTTP, HTTPS, TCP connections, coming in on these endpoints. Then we also have this notion of internal endpoints. And this is for instance-to-instance connectivity within your application. To have a particular virtual machine talking to another particular virtual machine, or a particular role instance in PaaS, talking to another instance. Here you can open up, ranges of ports, and the communication boundary here typically is the boundary of your deployment. So it's the machines within your deployment that can talk to each other. We'll talk more about virtual networks in a while. If you make deployments in virtual networks, then that boundary is extended and machines within your virtual network can talk to each other. And lastly, of course, it's important to have a name resolution story with these options. So we provide a DNS service, which provides a DNS name for your VIP there, the input endpoint. And this is the familiar the name of your service, .cloudapp.net, domain that you are given. And then we also have two options for how you identify those IP addresses for instance-to-instance communication. If you're using a PaaS application, you can use the Azure Runtime APIs to look up other PaaS instance and get the IP address for its internal endpoint. For an IaaS application, you can use DNS to do that lookup. You can control the host name of the machine when you deploy it, and then you can just do a DNS lookup against that host name. The suffix is appended for you in the suffix is appended for you. I just need to turn this off because I think it's coming through on the sound. Let's get rid of that. There we go. The suffix is appended for you in the virtual machine, and instance-to-instance lookups can be done just using the DNS name. You can also use the DNS option with PaaS if you specify the VM name parameter in the csconfig file for a given role. Then that will define the host names for your PaaS role instances, in which case you can then use the DNS option instead of the runtime option for PaaS applications. Okay, so that's an overview of these connectivity options. Next thing to talk about is around how we make sure things are highly available. I'm sure most people are familiar with the ideas of update domains and fault domains that we have in Windows Azure. This is, for example, fault domain is, if you think about a rack with a top of rack switch, if the top of rack switch were to blow up, then the machines within that rack would not be available. So we think of that as a fault domain. And when we deploy a PaaS application, for example, we'll spread it across multiple fault domains so it's protected against that kind of failure. And similarly in IaaS, you can use an availability set to spread your machines so that they're not exposed to those kind of failures. And our SLA for availability, makes use of this. You need to be running at least 2 virtual machine instances to take advantage of the 395 SLA for availability there. You can also, for those load balanced input endpoints I talked about, you can use those with PaaS and also with IaaS. In the case of IaaS, you need to put them into what we call a load balance set. You put your virtual machines into a load balance set, and then you can do these load balance connections across IaaS role instances, IaaS VMs, as well as PaaS role instances. So this can give you a high availability story that's resilient to failures. And also, when we have to make updates to the platform, it can make you resilient so that as we roll out those updates, we don't take down all of your instances or all of your VMs at the same time. Okay, so that's just a quick recap there. What I just talked about is all about how you achieve high availability for an application in a single deployment within a particular data center, within a particular region. There are some times where people want to achieve availability across multiple data centers, and this is where Azure Traffic Manager comes in. So what is Traffic Manager? It's a DNS service. It's a DNS service think of it as a policy engine, and it also includes active health monitoring of your endpoints and automatic failover. So what do we mean by a policy engine? What it means is, at query time, each individual query gets a response that's computed dynamically based on the current state of the system. So typical DNS is very static. You have a particular DNS records, they're just statically served. This one, at each individual query, we're choosing, okay, which is the right endpoint to return for this query. Why do we want to do this? What can you achieve with this? Well, we can route users to the closest data center. If you're deployed in multiple regions, you might have a deployment in the US and one in Europe and one in Asia. We can then route users to the closest instance, which gives you much better performance for those users, much lower latency. We can fail over between endpoints. So if one of the instances goes down for whatever reason, we'll then detect that automatically and automatically route users through DNS to other instances to give you high availability. Availability for, it could be an application level issue or something, a natural disaster impacting an entire data center. And there's another thing you can do with Traffic Manager, and that is you can very easily remove instances in and out of rotation for upgrades. Now, there's other ways of doing seamless updates in Azure, such as the VIP swap for PaaS instances, but of course this can work with IaaS as well. It's simply the case that, you know, by just a single click in the management portal, you can say, okay, stop sending traffic to my, you know, my US deployment, please, and then the traffic will automatically go to your other deployments. So now you can upgrade your US deployment, you can test it, check that it's working, and when it's all good, you know, just click the button again and bring it back into rotation so the traffic starts coming in there again. So easy way to do updates. So within Traffic Manager, you'll see that it's a DNS level. It's a DNS level system. So you can see you have your vanity domain at the top, contoso.com. This is a CNAME record, an alias to this name, contoso.trafficmanager.net. And this is then a CNAME to the name of your cloud service. It could be, you know, my service in uswest.cloudapp.net and, you know, useast.cloudapp.net at the bottom. So you have this, you know, this CNAME, you know, relationship between the two. And there's 3 different policies, you know, load balancing methods that you can configure within Traffic Manager. Performance I talked about. Round robin is simply, it'll just pick one of your endpoints at random effectively. So, you know, your traffic will be evenly distributed across those endpoints. And then the failover is where you actually put a sequence on your endpoints, and it will send all the traffic to the first one unless that's unavailable, in which case it will then use the next one, or if that's unavailable, the next one, and so on down the list. Now, something that's very important to understand is that that failover behavior, that health monitoring and failover behavior is not limited to the failover policy. It is also included in the round robin and performance policies. All the policies have that health checking and failover behavior. Now, as mentioned in the keynote this morning, we've recently added support for Azure websites in Traffic Manager. So this brings these benefits of Traffic Manager for seamless updates, for performance routing, and for failover to websites as well as cloud services and you know, ISVMs and PaaS services. You can combine websites with cloud services in a single Traffic Manager profile. So, for example, you could have a cloud service running in a couple of different regions, and then you could have a website as a failover option to say, okay, if the cloud service is down, then failover to maybe a more limited user experience that's running as a website. You can deploy websites in multiple regions and use Traffic Manager to route traffic between those. You should be aware that with websites and Traffic Manager, you can only have one deployment of a website in each region if you're using it with Traffic Manager. With cloud services, you can do more. You can actually put 2 cloud service deployments within a region, within the same region, and use Traffic Manager between those. And there are some customers who do that, where they have very, very large deployments. With websites, you can't do that. Websites, you're limited to 1 per region, but the way websites works under the hood, it will provide high availability within that region at the website's level. So then the need is only across regions. So it doesn't cost you anything there to have that restriction. And notice also that websites, you have these different tiers of websites and so on. As a value add, this is something that's only supported in the standard tier. Okay. Now, I thought we'd do a little demo of this. Let's see if the demo gods are smiling on us today. So we can see here that I have 3 websites that are set up. These websites are, I've put them into the standard tier, and I've just used one of the standard built-in templates for these websites. So you can probably see better than me because it's very small writing from where I'm standing. You can see you've got, you know, a US West, a European, and one in Japan. So if I click, you should see this come up. There we go. It's the bakery site that I used for the US West instance. And you see it, so it's a Tomcat and a photo gallery site. So I've basically used three standard websites, you know, just vanilla templates. So I've made no modifications. So let's see how easy it is to set up Traffic Manager with these. If we go here, we can go to Traffic Manager, and we just say New, Network Traffic Manager, and we'll give it a name. And we can choose which of those load balancing methods we'd like. Let's go with the performance one. The performance policy uses a latency map that we maintain of the IPv4 internet space, and it's, you know, as each query comes in, it will look at that query and say, okay, what's the source IP address for that query, and then it will use this latency map to look up which of the deployments is closest to where that IP address is coming from. It's worth being aware that that is not your end user's IP address, typically. That is the IP address of their DNS server. The DNS queries come from their client to the DNS server provided by their enterprise or by their ISP, and it's that location that is used in the routing. Typically, these things are always close to the user anyway, within geographic scales, so this works very well. So I'm simply creating that traffic manager profile there. Now, initially, this will have, you can see it's inactive. That's because it has no endpoints to begin with. So let's go in there and add these endpoints. And here, it's simply a matter of choosing. You can choose a different type of endpoint here, cloud service or website. And as I say, you can use both. You can mix and match. So choose website. And here, that gives you the options. So we'll just do all three. And we're done. So you can see here. So as this profile is created, its traffic manager is now going and probing each of those endpoints to discover their health. Now, something you may be familiar with is that in websites, you can typically access the website via its Azure Websites URL, the name of the service, .azurewebsites.net. And if you want to use a website with a vanity domain, contoso.com, you need to configure the vanity domain to point to your website, but also within your website, you need to configure that vanity domain as a domain that the website accepts. If you think about websites websites itself is a multi-tenant system. So when a DNS query not a DNS query, an HTTP query comes in, it may be coming in on a port that is shared with other websites. So we need to know, well, which website was this aimed at, this query? And we use the HTTP headers in the query to determine that, which is why you need to have this whitelist of configured within a website to say contoso.com is a website that is a domain name that is used by this website and is one I would expect to receive traffic on. Now, the traffic manager, you'll see in a particular website's configuration, you can see the list of names that it accepts. And when I set up the traffic manager domain name pointing at the website, you should then see, here we go, that list of domain names has had the traffic manager domain added on automatically. So there's nothing additional that you had to do there. So that's showing that this website will now accept queries aimed at the traffic manager URL. And whilst you'll still need to use you'll still want to use the vanity domain, and you'll still need to configure the vanity domain in this list just as before. There's no change there. This is great for dev and test scenarios where maybe you're not bothered with setting up the vanity domain. You just want to try it out, and you want to actually use the traffic manager domain directly. So that's why we made sure that the traffic manager domain would also work, and there's no effort involved in setting that up. So you just have to hit this traffic manager domain, and it should just work. So if I go back to my list of websites, you can see the traffic manager domain is here. So if I click on this, now hopefully we'll go to the cake one, because the cake one is, there we are. So it's recognized that the cake website, if you remember, that was the one that was set up in US West, and that's the one that, standing where we are today, it's routed us to. If anyone has a VM in Europe that they want to open a browser in and try the other, then they're welcome. So, okay, let's go back to the slides. Okay. Okay, great. Okay, so we've talked about the traffic manager changes there. IPs and IP addresses, ACL's IP addresses. There's various features that we've been lighting up in this space. So let's talk about some of these. Make sure you're familiar. So we talked about input endpoints. These internet-facing endpoints that connections coming into your service. Something that's new in Azure is that we now have the ability to set up ACLs on these endpoints, so that you can control better who is able to access each of these services. And these can be it's a typical rules you have for configuring these ACLs, where you can specify either to accept or to deny, and you can put in a particular IP address or you can put in a subnet range. And for example, you could then lock down your RDP endpoint to only accept traffic from your particular on-premise location or some subset of locations rather than having it accessible more widely. So this has been a much requested feature, and we're happy to see that's there. Let me just show you where it lives in the portal. So if we are in the management portal and we just look at a virtual machine, if we just pick one, you can see here when we look at the endpoints, you can click at the bottom for the particular. You just manage the ACLs, and then you can just put in the details that you need, and you're done. It's that simple, So it's nice and easy. Okay, let's go back to the slides. Okay. So this is your ACLs. The next thing, just a quick recap on virtual networks. So a virtual network in Azure is a virtualization of the internal network space. So here, we're not talking about the internet-facing network connections. We're talking about within the private address space, 10 space or whatever space you've assigned, for your internal address space. It gives you full control over that space. You can choose, okay, I want my virtual network to be 10.0.0.0/8. And if someone else is also using the same space, well, you don't care because it's virtualized and you can all overlap with each other, and Azure will just sort it all out. So it gives you that control over your network space. You can create subnets to carve this up into smaller spaces. When you deploy a virtual machine into the network, it's assigned an IP address, and that IP address is then persistent. It doesn't change for that virtual machine. You can use the DNS service that we talked about to do this name resolution between instances. You can also configure DNS settings that replace the Azure provided DNS service with a DNS service of your own, which can be running either on-premise or you can run a virtual machine running the DNS service. You can ACL the machines. We talked about ACLs already. You can use this for large-scale deployments in the cloud, and you also have options for how you connect this virtual network to your on-premise network. And this is an area that my colleague Ganesh will talk about in the third section of this talk. So one of the things that we've added very recently is what we call static virtual network IP addresses. So before this feature, the way it worked was that your IP address was stable, but it had to be assigned by Windows Azure. So you'd deploy a virtual machine, and until you deployed it, you wouldn't know what the IP address was going to be. And once you've got the IP address, great. Now you know what the IP address is, and you're done. It won't change from that point onwards, but you didn't know what it was going to be in advance. And there was a few situations where that was a little bit awkward, because perhaps this machine is actually my DNS server in the example I gave earlier. And I would actually quite like to know what the IP address of this machine is going to be, because I want to put it into my VNet settings as the DNS server for that virtual network. And that becomes a bit of a cyclic dependency, doesn't it? So whilst there's ways around that, you can go and update the VNet settings afterwards. This is a much cleaner solution, is that now at the time you're setting up the virtual machine, you can specify its IP address explicitly yourself. You can say, I want it to have this IP address. This is something that's a PowerShell experience at the moment. And there's one example given there for just specifying a particular IP address on as you set up a particular virtual machine. There are other PowerShell commands there to test if a particular IP address is available. So you can obviously put in that, that check beforehand. And you can also reassign a new IP address. You can, remove an IP address from a particular machine and, make various other changes. So you have a kind of a full set of management operations there to control the IP address on a particular machine. And as I say, it makes certain scenarios where you need to set up a DNS server, or maybe you're setting up, ACLs or whatever it is. It makes some of these things, easier to manage. Another thing that we've added recently is the ability to move virtual machines between subnets within a virtual network. So in the past, once a virtual machine was deployed into a subnet, then that's where it lived. And to move it, you really had to tear it down and recreate it in a new location, perhaps from the same drive. Whereas now we have the ability to actually set just set the subnet for the virtual machine on an existing machine, and then when you reboot the machine, it will reboot and get its new DNS DHCP settings from the new subnet. So if one of your subnets, maybe when you created it, it was a little bit small, and you'd like to move those machines into a new larger subnet, whilst you can't resize the subnets, you can just create a larger subnet and then just move the machines across. So that's makes that migration much easier. Or maybe there's a subnet that you created that was too big, and it's using up too much of your address space, and you'd like to move to a smaller one. Again, you can migrate the machines out of it. So it just makes that management of the the life cycle of these machines over the long term much easier. And there's an example there for the PowerShell. It's just a simple command to specify the name of the subnet for the particular VM, as part of the VM setup parameters. Okay, so now I'm going to hand over to my colleague Ganesh. He's going to talk about some of the changes we've been making in the connectivity options for Azure.
Thank you.
Here we go.
Thanks, Jonathan.
Thanks, Ganesh.
Hey, everyone. My name is Ganesh Srinivasan. I'm a program manager just like Jonathan in the Windows Azure networking team, and my primary area of focus is hybrid networking. All I do is figure out how you can extend your on-premises network into the cloud and support you with various different connectivity modes, whatever you choose to do, whether it's dev test, prototyping, or running simple scenarios, or actually moving your entire enterprise workloads and mission-critical applications into the cloud. So there are quite a few interesting, not really new features, but announcements that we have today. I will cover some of them in brief detail here. And there's actually a second session later today where I'll be focusing on one of these areas in great detail. I'll be spending about an hour talking about just ExpressRoute later this evening. It's a cool new feature that we put in preview last month, and we'll just look at what it is today during this session. And if you're interested in knowing more about it, we will look at it in greater detail later this evening. So with that, there are three main connectivity modes that we support in the platform when you want to extend your network into the cloud, which is when I talk about hybrid connectivity and connectivity solutions that we offer, it's all about how you can reach the instances on their private IP addresses and not through the public IP addresses through the public internet. So if you wanted to connect to any of your services, be it a dev test scenario where you just want to put some of your code out there, connect to it through the backend to gather logs or traces or debug events, you could choose one kind of a connectivity model. If you want small amounts of data transfer going back and forth primarily for monitoring, identity, and so on, you could choose a different connectivity solution. And if you're really trying to push gigabytes or terabytes of data or even petabytes of data from your premises to the cloud, we have solutions for that. So with that, let's get started. So about a year back, we introduced this ability for you to have set up a virtual private network in Azure. I think when we announced infrastructure as a service, as a generally available service, we added the ability for you to establish a point-to-site connection, which is just like how you would VPN into your corporate networks, you could actually VPN into a virtual private network that you have in Windows Azure, and you could essentially have private connectivity to your entire network. So you could use private addresses for your front ends and back ends. You could mix and match IaaS instances with their PaaS instances and build services. When you do that, you would still have this back-end connectivity. That is, I'll cover that in detail, but essentially what it lets you do is it lets you have this private connectivity, a very lightweight connectivity where you don't have to go get IT policy approvals and all that to establish this private connectivity. It's called point-to-site connectivity, and we are very happy today to say that it's a service that we will be supporting as a generally available service, which means we will slap an SLA on top of it. There is an availability SLA associated with it, and you can start using this for your production services without having to worry about this being a preview feature anymore. So we've been in preview, as I mentioned, for close to about a year. And we've had several thousand people try this out, and we've had very good feedback, and we've tried to incorporate quite a bit of feedback into this product. The other type of connectivity that we've had for quite a while now is the ability to use a site-to-site VPN to essentially connect the virtual private network that you have in Windows Azure to your premises. So you can set up a standard IPsec VPN and have packets going back and forth between your premises and the cloud. And it's a pure IP-level connectivity that's secured using the IPsec protocols. When we started off offering this service, we only supported policy-based VPN devices, and that heavily constrained the device families and devices that you could use for connectivity. And in some families of devices, it even posed challenges on the configuration of those devices. As you added more and more subnets on the Azure side, the configuration policy for your VPN device became extremely complex. So we moved away from, not really moved away. In addition to supporting policy-based VPNs, we added support to be able to do route-based VPNs. So that opened up the ecosystem to a larger number of VPN devices in the platform. And just the way we did with point-to-site, as of today, we are happy to announce the fact that dynamic routing gateways, that's the term we use to refer to route-based VPN devices, is also generally available. So if you have large-scale routers that are purely route-based, you can use them with SLA to connect to Windows Azure. In addition to the fact, we have started the process of qualifying a lot of VPN devices. We've added specifically Checkpoint and Fortinet to our device family list. And we've also validated some of the open source VPN devices like OpenSWAN with our platform. So, and down the road, you will start seeing a lot more VPN devices being qualified, validated, and announced pretty soon. And it brings me to the third new service. This is an exciting service because personally to me, I've spent the last year and a half working on just this last item, which is called ExpressRoute. ExpressRoute is a brand new service that essentially enables you to bypass the public internet and connect to Windows Azure. There are essentially two modes in which you could connect to us. You could essentially meet the Microsoft network at an exchange provider facility, such as the ones that are run by Equinix. Or you could actually use your WAN provider who interconnects all your branch offices to actually extend your WAN into Windows Azure so that Azure just looks like yet another node in the entire WAN network that you have and you maintain. So we've announced partnerships with AT&T, Equinix, and Level 3 in that front. And I'll cover that briefly during this session. But I'll do a deep dive on how each of these things work in the session later this evening. So with that, as I mentioned before, point-to-site VPNs essentially gives you the ability to establish a secure, private SSL-based VPN, not really SSL, but it's SSTP, Secure Sockets Tunneling Protocol-based VPN service between any of your Windows-based machines that you run and a virtual private network that you set up in the cloud. A typical scenario for something like this would be if you were to essentially want to build an entire multi-tier application that's running in the cloud, but before you released it, you wanted to debug that application, or you wanted to do something where you wanted to have some sort of a back channel into that infrastructure that's purely running in the cloud. You don't want to come and reach the application from the internet. A good example would be you're running your front end as a PaaS application and your back-end tier as a SQL Server cluster. In such a case, you may want to set breakpoints on your code that you're running for your PaaS application, get traces, debug it, or do load tests. As you're doing load tests to the front end, you may want to capture statistics or traces on the back end from the SQL servers and so on. So if you wanted to do that, and typically when it takes, cloud is an ideal platform for doing prototypes. But when you're in the process of doing these prototypes, you don't want to be weighed down by IT processes. Typically, getting private IPsec VPN set up is going to take you a few months to get policy exceptions or approvals and so on. And then you have to buy a device, rack it and stack it at some endpoint, put it at the edge of your network, and establish an IPsec tunnel. Now, that's going to hamper any progress that you can make with a project. So we wanted to use or come up with a solution where you could do that without having to install a single line of code on your Windows box. So the good thing that was happening for us is the fact that the Windows Server and client OSs actually have built-in VPN clients in them. So we wanted to figure out if we could take advantage of the fact that Windows already supports a built-in VPN client to establish connectivity between Azure and your premises. And that's what resulted in building this point-to-site solution for us. Before we went ahead doing this, we had a product before this, which is called Windows Azure Connect. Now, Windows Azure Connect was also an overlay network-based solution, but it relied on you installing an agent in your machine, essentially to get connectivity back to Windows Azure. Now, an agent-based model, though it works really well, we received a lot of pushback from the customers because A, you're installing some code on your SQL server or your domain controller, which is not really something you want to do. It's still third-party code that's not trusted. So that approach, though worked well, did not go well with customers such as yourselves. And that's what made us to invest in this point-to-site solution. So we'll look at how it works and what it does. A couple of principles that we had when we designed the service was that A, as I mentioned, no software installation. With Windows Azure Connect, we learned that the agent model does not work. Secondly, it should be easy enough to set up that someone with very little or limited networking knowledge can set this up and get this going so that they can prototype without any worries or any difficulty. And then it should be basically built in such a way that you don't have to worry about where you are. You should be able to tunnel through firewalls and proxies and be able to connect to Windows Azure. And you may be prototyping at this point in time, but down the road, you may want to essentially use the same setup for your production, which means connectivity for whatever you do for your prototyping should coexist with what you would do when you move to production. So those were the principles that we wanted to follow when we designed this solution, and we came up with this solution. So let's now walk through the process of how you would actually set the whole thing up end to end. I'll do a quick review of this here, and then I'll do a demo of what it takes to set this up. So you'll see that as I'm done with this walkthrough and the demo, it'll take me about 5 minutes to set the whole thing up end to end. So you, as the admin, would first basically author up a network configuration. There are two ways in which you could do it. The first thing you would do is you could use the wizard that's supported in the Windows Azure portal to create a virtual private network. This is you can bring your own IP address range into Windows Azure. We support all private IP address ranges that you can bring into the cloud. You can bring your 10.0.0 entire 10 space, 192 space, 172 space, or subsets of them, or in whatever combination you want into Windows Azure. You can then essentially carve out smaller subnets in them for placing different roles of your services. So once you've done that, you have the option to create a virtual private network gateway for that. And when you actually ask for a virtual private network gateway, we actually create two software VPN gateways for your virtual network to offer connectivity. We actually create two because we run them in active passive mode. That gives you a high availability guarantee on the Azure side. So if one of the VPN gateways goes down, we have logic that will automatically detect and fail over the VPN gateways in about 30 seconds. So you can create a VPN gateway. So once you've done that, if you're doing site-to-site VPN, if you can specify some of the common models that we've actually listed in our portal, if you pick one of them, you can actually download a pre-populated VPN configuration script that you can just open your command line interface for your device and just run that script. So as an example, if you're using Cisco's ISR series of devices, once you've created your gateway, just go to our portal and say, I have a Cisco ISR 2911 or 1900 or whatever model you have. In response to that, you would download a script, and it'll have all the subnets and all the policies actually predefined in them. So you can copy the entire script, open an SSH session with the device, and completely run that script. And at the end of that 2 minutes, your VPN device will be connected to our VPN, to the software VPN in Windows Azure. The other cool thing is we've enabled Windows RAS server as a soft VPN gateway. So you can do the same thing, set up a virtual private network, and at the end of that exercise, you can say, I want to use an RAS server for my site-to-site connectivity. And what we would do is we would actually give you a PowerShell script. And assuming you just have a vanilla Windows server with nothing installed in it, if you run that PowerShell script, it would set up RAS server as a server role in your machine, plumb the right IP addresses and policies, and configure the RAS server to offer the site-to-site VPN capability. So by just running that single PowerShell script, you've established site-to-site connectivity between your premises and a server that's running in your premises. Now, if you wanted point-to-site capability, what you would actually do is at that point in time, upload certificates. We would need some way to authenticate users who want to connect to us. We could either use usernames or passwords. It works well. The other way to do it is when it scales, maintaining usernames and passwords and compliance becomes a bit of a challenge for a lot of people. So we said, let's use certificates. Already a lot of people use certificates to authenticate against Windows Azure when they use PowerShell or any of the command line tools or REST APIs to program into Azure. So why not use that same concept? So we ask you to generate a root certificate, which is a single certificate like a CA certificate, but you can do a self-signed root certificate and give us the public key of the root certificate. And from that root certificate, you can generate as many derived certificates from that. And you could give each of these certificates with the private key to the people who want connectivity into Windows Azure. So they could actually install these certificates in their machines. And then once you're done with that, you can download a VPN client package from the Windows Azure website. I'll show you all of that. But all that package contains is basically configuration that tells you, if you wanted to connect to Azure, here is the public IP that you have to connect to. And here is a certificate that you should be using for authentication and so on. So once you've downloaded that package and installed it, you will actually see it in the list of, just like how you see your Wi-Fi networks and your wired networks in your Windows machine. This will show up as a VPN option right there. You click on it and say connect. Within a matter of seconds, you have this SSTP tunnel established between your machine and Windows Azure. So you are downloading a package, but it has got zero code in it. It's purely config that's configuring the VPN endpoint on your machine. You could choose to do the same thing with all the information you have by yourself, but this package simplifies the whole thing for you. So once you've downloaded that and installed that client, you have this private IP connectivity, and you can reach any VM or any PaaS service that's deployed within that cloud virtual network on any IP-based protocol other than multicast and broadcast through that VPN tunnel that you've set up. OK, so before I go to site-to-site connectivity, let's look at a few things in the Windows Azure portal. The first thing is let's look at how you use the wizard to create a virtual private network in Windows Azure. How do you configure point-to-site connectivity? How do you configure site-to-site connectivity? Where do you upload a certificate? Where do you download a VPN package? Where do you download the VPN configuration script? We can see all that in the next 5 minutes. I'm going to switch to my subscription. So typically, whatever I'm going to be talking through is all documented in windowsazure.com. If you go to windowsazure.com, look at features and documentation, you would be able to download tutorials and step-by-step guidance on how to set up whatever I'm doing right now. So it's a very straightforward process to go through. So I'm going to move from Jonathan to So just like how Jonathan created the traffic manager endpoints, there is a wizard that you could use to create a virtual private network in Windows Azure. Now, in the list of services, you do see virtual networks listed, and I have quite a few of the virtual networks. Let's create a new virtual network. You go to Networking Services, Virtual Network, and we're going to use the custom create wizard to basically create our virtual network. When I create a virtual network, I need to give it a name. So I'm going to say build demo vnet. And you have to specify a region in which you have to create it. One way to do it is to create an affinity group, place the virtual network in that affinity group. I have a few pre-created affinity groups here. I believe I have one that says Okay, I'll use the US1 West SVC. It's a US West location, which is in the west coast of the US, so we'll get the best latency possible. You picked a name. You now have to specify whether you want site-to-site connectivity or point-to-site connectivity or both. So you can select, I want to have point-to-site connectivity. I need site-to-site connectivity. And here is an extra option where I can actually specify if I wanted to use express route for this virtual network or not. I'm just highlighting this. I'm not going to select that for the time being. But if you were to use express route with your virtual network, you check this option. And when you create your virtual network, it will be enabled for express route. You could either use one of the pre-existing sites or say, I want to define a new site for my connectivity. So with every box that I check, you can see that the number of steps I have to go through in my wizard just keeps increasing. So the next thing I'm going to do is I'm going to first configure my point-to-site capability, which means I have to connect from my VPN client in my machine to a virtual network in Windows Azure. And the VPN client in my machine needs to get a private IP address. It's got to be something that is routable within the virtual network. And I can have up to 256 roaming VPN clients. So I have to pick a subnet that has up to 256 IP addresses in them. So for the sake of the demo, let's pick the 10.0.0.0/24 as the subnet. We use CIDR notations for specifying subnets. And what this actually means is you've got the IP address ranges 10.0.0.1 to .254 available within that subnet for you to use for instances. So we'll go ahead with that. You can actually carve out multiple subnets and mix and match ranges if you chose to. We support that. For the sake of site-to-site connectivity, I'm saying I want to connect to some location. I could say, I'm just calling it build prem, and I need to specify a public IP address. This is the IP address of the VPN endpoint that's sitting on the other side. That's the premises side of the network. So I'm just going to make up an IP address for now. And then we do set up static routes at this point in time. So I need to know what is the address range that's actually on the on-prem side of the network. That way, I know that any packet that's destined to that range has to be tunneled through the VPN gateway to the other side. So in this particular case, since we used 10.0/24 for the point-to-site case, let's use 10.1.0.0/16. I can add more address ranges. I could add a 192 range or whatever range as you need. And then I would actually specify my virtual network finally. This is the virtual private network that you want to run in Windows Azure. And for that, just to make a difference, let's go ahead and create a virtual private network that's a 192.168 address range. And I could add more ranges. And within that, I could specify multiple subnets and so on. And I could add as many subnets as I wanted. At the end, for me to be able to deploy a software VPN gateway, we deploy dedicated VPN instances for you, and they have to sit within your network. So for that, we ask you to carve out a small subnet within your virtual network so that we can deploy our gateways into that subnet for you. So I have another /29 subnet just for that purpose. So at the end of this operation, I have specified my point-to-site connectivity requirements. I've specified my on-prem ranges for site-to-site routing, and I've specified the address ranges that I plan to use in Windows Azure. So, and the virtual network is actually ready. The next thing I'd have to do is basically go to this virtual network, and you would see that everything appears in red. That's because we've not started the VPN gateway. You could go and change the configurations in the Configure tab, and you can upload certificates in the Certificate tab. We'll get to that in a minute. But the first thing you want to do is click on Create My Gateway. This is the operation that kicks off the process of actually creating and configuring the soft VPN gateways for this particular virtual network. This operation can take from 4 to 6 to 8 minutes, and at the end of it, it will have these two instances pre-configured. Just to save time, I'm going to switch to another virtual network that I've already pre-created to continue with the demo. So once you've got the virtual network gateway up and running, the next step that you want to do is essentially upload your soft VPN, the certificates that you want to use for authentication. So I just pointed you to a tutorial in the Windows Azure website. It has instructions on how you can use Visual Studio tools to generate certificates. So once you have these certificates, all you have to do is just upload the public key of your root certificate into this certificate tab. You could just upload it just the way you upload a management certificate, point it to a SIR file and say OK. And at the end of the operation, you have the certificate uploaded and available for use. OK? And let's go back to the dashboard. Now, you saw that site-to-site is red because I didn't configure my site-to-site VPN. I could actually go and say, it's really hard to read from here. The third option is to basically download the VPN configuration script. The VPN configuration script essentially is the pre-populated script that you can use. So I could say, for Cisco, I'm going to use ASR, and I'm going to use iOS 15.1. At the end of the operation, you have a well-commented script, including a pre-shared key in it that you can just blindly copy and paste in your VPN device, and it would configure the ASR device in this particular case as a site-to-site VPN and establish that VPN tunnel with Windows Azure. So we go from AES-256, which is the strongest crypto key, all the way down to triple DES if you choose to, and you can choose to block it by configuring an appropriate policy on your side. You could also vary the pre-shared key length. We generate a long key by default, so you could do all that using advanced APIs and PowerShell calls. Now, the more interesting thing is you want to do point-to-site connectivity. Now, for that, you can download a 32-bit VPN client or a 64-bit VPN client, and just clicking here would then again give you a download box that you can download. And while it is downloading, I've actually pre-downloaded a copy just to save time. It's already ready there too, so I can run that. When you download this package and run, don't be afraid if it gives you a pop-up window saying this is untrusted. We do not sign these packages. That's the way we sign all your Windows drivers and packages. We don't have the ability to sign on the fly and runtime when we generate these packages. If you're concerned about that for your enterprise use, you can always feel free to run it by your signing authority and have that package signed. So right now, I actually, since I have this dual monitor, it's running on this end, and the VPN configuration is actually done. So since I can't show this monitor, imagine you're seeing the icon where I click on, where you look at all your Wi-Fi operations. And you would see a VPN client package like this show up when you double-click on that icon. And it says connect, disconnect, and properties, and so on. All you have to do is connect. And that's it. Right now, this machine that's here, the demo machine right here, is connected to my virtual network. And it's all good to go. So let's now look at whether it's actually done. So when I do an IP config, you can see that this thing got an IP address of 192.168.0.7. So it's actually indeed got a private IP address from the VNet range that I configured. I used the 192 range for this virtual network. And I have a virtual machine running in the virtual network that I'll show you in a bit. And as you can see, since we are pretty close to our US West data center, it's a 5 millisecond latency through the VPN tunnel from this demo box to your virtual machine that's running in Windows Azure. And if you logged into the portal, you can actually see that I actually have a virtual machine. And it gives you the number of VPN clients that are currently connected. So as you connect more and more, you'll see that counter refresh periodically. So this was a quick way for me to show you point-to-site and site-to-site in action pretty easily. So if I had a VPN device here, which I don't, I would have loved to actually run that script and show you that it works really fast. So as I mentioned, when we started off with this a couple of years back, we just supported Cisco and Juniper devices. And as of last year, we added WatchGuard, Citrix, and F5 as VPN devices. And as of today, I'm excited to tell you that we validated Checkpoint and Fortinet as VPN devices. We also have validated OpenSWAN as a soft VPN device, which means, since most of it is based on OpenSWAN, you can expect a whole bunch of open source related stuff to run without you having to worry about validations and so on. One note that I wanted to make here is that we've validated them, which means other than Windows Server 2012, our support guys will be able to give you guidances and so on, but we would encourage you to contact the vendors to actually get detailed support on the device, because our ability to debug deep concepts of that devices are limited. So we've talked about the case where you can connect on demand, on the fly in a very lightweight way without installing software. You can do site-to-site VPNs over the public internet, which is secure over IPsec. But a lot of enterprises and large-scale organizations are paranoid about the fact that you're connecting to the public cloud over the internet. While this works, while it's secure, compliant, and so on, it's still, for some reason, there's some apprehension in adopting the public cloud because it's over the public internet. We want to make the cloud services available to you over the private internet, or a private connectivity mechanism, by completely bypassing the internet. It gives you quite a bit of advantages. First of all, you basically are not at the mercy of the internet, which no one controls, and you don't have any guarantees on SLA, on latency or jitter or throughput or anything for that matter. So that's a scary part. Secondly, there are single points of failure, and you may be impacted by that. So we wanted to eliminate all that and kind of offer you a very trusted connectivity mechanism to connect to the cloud. And that's what's really ExpressRoute for us. ExpressRoute is one of the first services that we in Azure trademarked. So we gave it the name ExpressRoute. It's like using the HOV lane. You bypass the internet, and you get a fast path into Windows Azure. So what is it? It's essentially a private high-speed network connection that lets you connect your premises to the cloud by bypassing the internet. It gives you predictable performance because you are either directly paired with us, or you come through a carrier and connect to us, who offers you an SLA on connectivity. It's highly secure because a carrier enforces that the network is secure, and we ensure that from the point we pick it up from you or from the carrier, we isolate it and carry it all the way up to your virtual networks or your services. It's got high throughput. You could go all the way up to 10 gigabits per second with this kind of a link with a single circuit, and you can buy multiple circuits if you wanted. And if you're pushing large volumes of data, we don't charge you at internet rate. We have special rates for this. So essentially, when you're moving large volumes of data, it's going to be a lot more economical. The other cool thing, which is a big difference between what we've had with virtual networks, site-to-site and point-to-site connectivity, is the fact that with the other technologies, you could only connect to virtual machines and PaaS services that you had in Windows Azure. With ExpressRoute, you can now connect to all of the Windows Azure services without having to go through the internet, like Windows Azure Storage, websites, media services, SQL databases, Azure Active Directory. Pick the service, and we would be able to route them to you securely through a private channel. The other cool thing is that we learn routes from you, and we publish our routes. So as and when you create new accounts, you don't have to reconfigure anything in your network. We will automatically learn, push the appropriate prefixes to you. You will learn, and you'll be able to route. And we've also built high availability capabilities into the platform. So even if a router goes down on your side or on our side, we have abilities to make sure that connectivity stays up, even though this goes down, a single router goes down. So I just wanted to put this in place to just get you to think about this. I have a full session, an hour-long session on ExpressRoute and the various benefits of using this technology with Equinix and AT&T and Level 3 and all that later this evening. If you're really interested in this topic, I would urge you to attend that session later today. So we have about a minute to go, and I'd like to quickly summarize what we had today. So we had quite a few new features that we're talking about for the very first time. One is the fact that Traffic Manager was generally available. Secondly, as you saw in the keynote, we had Traffic Manager with websites officially announced today as a generally available feature. You could statically assign IP addresses for virtual machines, which was a big pain point for a lot of people deploying domain controllers and so on. You could move VMs from subnets so you can actually plan your networks better if you didn't do it the right way the very first time. point-to-site and dynamic routing gateways are generally available. You do have new VPN devices that you can play with, and we do have ExpressRoute, which I truly believe is going to change the way people connect to Windows Azure. So with that, I know I'm almost out of time. If you have any questions, I'd be happy to answer them. Thank you.